Thank you for your patience, folks, for the technical issues that are always complicating. I was asked to announce before I started my talk that you can record or take photographs for the first 5 minutes, but nothing after that. That's the kind of the rule for this room, apparently. My name is Anshul. I'm a senior manager at NVIDIA working in the AI for graphics teams. And this is my colleague and friend, Ambrish, who's also my peer in the same team. Today, we're going to be talking about AI assistants for games, specifically those that help onboard new players, as well as seasoned ones to keep up with the deep and often dynamic intricacies of a game universe. So we're going to be talking about that. I'll do the first half, and then Ambrish will do the second half. Allow me to start by motivating the core problem here. It is likely no news to anyone in this room that a hallmark of modern games is the rich and complex universe that they weave for their players. Whether it is hundreds of skill permutations, tens of game elements, or a large character hierarchies that we have, today's game offers players countless ways of experiencing and engaging with their virtual worlds. This is generally a great thing, and I'm sure it's the reason many of our favorite games are indeed so engaging and so compelling, and we keep going back to them. However, at the same time, this complexity can often limit engagement by newer players who are just starting to play a new game or entering a new virtual universe, making them often quit or pause gaming too early and too often to fully enjoy the experience. Furthermore, the same complexity can affect seasoned players as well, who often report experiencing fatigue or significant mental barriers to replaying a game or restarting playing a game just because of the amount of complexity or intricacy it might offer. So it's as necessary and as awesome it is to have the deep lore and complexity in these video games to ensure enjoyment and infinite replayability. Sometimes it can cause limitations to how well our players engage with them. There already exists a large section of the internet trying to address this challenge. Hundreds and thousands of wikis are dedicated to different video games, and there exist countless official as well as user-generated guides, builds, and playthroughs, many of which we have probably used and experienced over our gaming experiences. Often, engaging with a guide or a wiki or a playthrough like this involves us exiting or minimizing the game that we are playing and searching for that specific scenario or situation that is bothering us or causing us to not make progress in the game that we are playing. And then we have to search for that specific query in a browser and hope for the best that the right answer is somewhere on the internet. Some of you might agree that that's not a very streamlined experience. Often, when I alt-tab out of a game, I might not even go back into it. I propose that AI gaming assistants are a solution to this problem. Some of you may have come across Project G-Assist, a prototype gaming assistant that we demonstrated at Computex in 2024. Based on our experience building that AI assistant and further work in building more efficient and practical versions, today we will outline how one can build an AI agent to navigate the challenge of interface, context awareness, and language processing. To help navigate the game complexity without leaving the game, and to help provide context-specific responses to the natural language queries. I will first talk briefly about these challenges, walking through a very high-level architecture of a practical and helpful AI game assistant. I will then hand over the mic to Ambrish, who will present the details about the architecture, various building blocks, and some best practices for anyone else trying to build AI gaming assistants. So let's get started with the no assistant scenario. A player is playing a game and encounters an unknown situation that prohibits them from processing. It's confusing. They don't know what the next step is. They are dying too often. They don't know what to do next. They all tab into their browser and ask a question and hopefully get a reasonable answer. Then they go back to their game and continue playing. The first step in streamlining that experience is to install our agent somewhere within the same environment as the video game. Perhaps it is an in-game experience of a user interface that allows you to access the guide within the game. Perhaps it's an externally controlled overlay, for example, in the demo that we gave at Computex. An even better interface would directly allow your users to talk to the assistant rather than having to type their query. So playing a game, still continuing to use your mouse and keyboard, press a hotkey, ask a question, continue to play, and receive the answer as if you're talking to another person. And all that backed by some form of a language model to understand and respond to the actual queries that the user is placing. However, a language model by itself, we found, is not very capable of answering questions about the intricacies of the games that we want them to answer. Specifically, they have trouble with reliability of the answers. Here's an example of a question from my favorite game, Dota 2, where asking a very simple question, very easy question to answer, can sometimes produce answers that are completely irrelevant or outdated. So we need our language models to attach to a knowledge base that is updated and easy to update as the game naturally and dynamically changes over time. Also for games that our models may never have been trained for. So a practical alternative that we rely on is a retrieval augmented generation setup, or a setup where you take a well-curated database of the game. Perhaps it's a wiki or a manual or some sort of question forum or frequently asked question set of documents. Distill them into a vector database and use your query to fetch the relevant portions of that database that will be useful to answer that query. These relevant data chunks then accompany your query to talk to the language model and receive relevant responses. In essence, this is an example of in-context learning, where the job of the language model entirely is to look at only content in the prompt that it's given and produce all answers from there. It is asked specifically not to answer questions from its own knowledge to avoid providing any out-of-date or out-of-context answers. And as long as the retrieval from the vector database is accurate and robust, usually a user's query would be correctly answered. Another question that we had while building the language model backend for a game assistant like this is whether to use cloud-hosted or on-device language models. Many of you have heard of terms like large language models and small language models. We found that if you have an appropriate and a robust RAG workflow, it is possible for the on-device SLMs to provide reasonably accurate answers, which by large match what a large language model would produce in their detail. Certainly, the small language models are less capable, but we find that they're quite robust in capturing the essence of the answer that the user requires. And so then our architecture of the game assistant can be modified to be the following. We take the language model a little bit further and add an agent controller, which is communicating with a vector database that contains the knowledge base for that particular game. The next step is to be more context sensitive for the user. So I may ask if I'm playing and I have a seamless, streamlined user interface to interact with while asking questions, I want that assistant to be aware of what I'm doing in the game. So I can ask questions like, why did I just lose this battle? Who is that character? What should I build next? And without having to describe exactly what I'm doing or where I am. In other words, I want the assistant to be aware of the current game state, so the answers are relevant to that particular level, that particular character, that particular enemy, and so on. And so as long as your agent is built within the game, you can probably pass that information along as part of your prompt. But if that's not the case, if your agent is an overlay outside the game, then you can use context awareness using other methods, specifically OCR and vision processing. These lightweight models can help us parse the text that's on the screen and the icons that may be on the screen specific to that game, and utilize them as additional inputs to the language model, again for the in-context learning problem. Alternatively, the game can just provide that information. If we have access, if we are developing the game ourselves, we can directly provide that information to the agent. In the future, it would be interesting to see if vision language models are useful in this problem. So the last and final step of building our context-sensitive, responsive, updated, practical, useful agent is to add a vision or a game-assisted game state processing workflow that will provide this controller with information about the game state. And the job of this controller then is to take the three sources of information, the user query, the current game state, and chunks from the vector database that are relevant to the query and the game state, and then feed it to the language model alongside a carefully designed system prompt to receive the answers for the query. And these three are the main features of the agent that we discover are most beneficial for producing the right answers in a small resource footprint. At this point, I'd like to hand over to Ambrish, and so he can talk about these units in a little bit more detail, show some of the best practices, and I think he will start with a video showing the demo from Computex.
Yeah, I'll just do that. Complain, just give me a minute. Yeah.
Thank you, Anjul. Hi, everyone. I'm Ambrish. I'm a senior manager for AI for Games team at NVIDIA. And I'm going to be talking about the how part of building an AI assistant within a game. We'll talk about the models, the architecture, also the learnings from our journey. With that said, let's start with a video or demo video of the AI assistant that we built. Because of the setup issues, we are going to play it from YouTube. Yes. Let me hit it right.
Yep.
Today, we're excited to share Project GAssist, a demo showcasing how developers can enhance games and apps with AI assistants. Many games offer vast universes and rich gameplay systems to explore, each with its own intricacies and mechanics. Depth has become...
Go ahead.
I think
the other guys setup issues.
We have to go out of presentation mode.
And go here.
The cornerstone of today, we're excited to share Project GAssist, a demo showcasing how developers can enhance games and apps with AI assistants. Many games offer vast universes and rich gameplay systems to explore, each with its own intricacies and mechanics. Depth has become the cornerstone of some of the most captivating gaming experiences. Whether it's a new player trying a game for the first time, overwhelmed by massive skill trees, or the seasoned veteran looking for that perfect weapon to min-max that DPS build, many of us spend hours researching, scouring the internet to learn, to dig deeper, and ultimately enjoy more of what the game has to offer. This is where Project GAssist comes in. It uses AI to make sure information is readily available whenever we need it. It works by taking in speech or a text prompt from the player, along with context from the screen, and then it feeds this into a large language model that is enhanced by the developer's game knowledge database. These AI models can run on the cloud or locally, accelerated by your GeForce RTX GPU. To show you what's possible, we've partnered with Studio Wildcard for a tech demonstration using Ark Survival Ascended. The assistant is your conduit for game-specific knowledge. You can ask it questions you often find yourself looking up online, like, what's the best early game weapon and where do I find the crafting materials for it?
The best early game weapon is the spear. It provides knockback and is essential for survival.
Not only does it know about the game, it can understand what's happening on the screen. Maybe you're staring at a dinosaur you're not familiar with and you want to know what it is or how to tame it. And because the assistant is context aware, it can tailor its recommendations to your playthrough. Say you've racked up enough points to level up or to unlock a crafting recipe, but you're just not sure what to go for next. And if you want to dive deeper into a topic, you can simply click on the response to learn more at the official wiki, for instance.
All right. Let's continue our presentation. So this is an example of the AI assistant for our game that we built. The key things to notice about this demo is that this is a fully local AI assistant. It's running entirely on your local system, on your GeForce GPUs, not running in the cloud, thereby minimizing cloud cost. It can take inputs in text form or speech form, thereby making it easier to interact with. And it is optimized for that specific game, for accuracy, for relevancy of answers, and to improve overall user experience. We are going to talk about how did we build this agent, how we can use that work that we did to build this kind of an agent to bring that AI assistant into other games. How can a AI app developer or how can a game developer use this work to create their own AI assistants? And we'll also talk about how do you optimize an AI assistant with respect to performance, accuracy, relevancy, guardrails, all of those aspects. So let's dive into the details. This is essentially our architecture for implementation of this assistant. Creating an AI assistant is a multi-step process. The very first, you need to build a knowledge database for the game. Your SLM, your language model, needs to have all the relevant information about the game for which it is answering questions. It is done by creating a vector database or a RAG for that specific game. What we did is we used a game wiki for our game and for other games as well as our source of truth. We used that data. We created a RAG solution using that. While we were doing that, we wanted our RAG to be performant and accurate. We experimented with different RAG solutions, and eventually we implemented our own C++ RAG solution that was optimized for this specific use case. The next step, once you have the knowledge about the game, the next step is to build an understanding of what is happening within that game. If you want to answer questions, what level you are at, how is your health, how many weapons you have. Essentially, you want to build an interpretation of your game state. To do that, we used a computer vision model and an OCR model to interpret what is happening on the screen. We used NVIDIA's frame capture library to grab game frames. Then we run them through a computer vision model. In this case, we used a model called RT-DATR. And you run it through an OCR model to read what is written on that screen. In this case, we used Easy OCR. Once we run a captured video frame, captured game frame, through these two models, we have an understanding of what is happening on that screen. And using that interpretation, we build what we call a game state, essentially a representation of where you are in that game. So we got our game knowledge, we got our game state, all built programmatically. Then you want to transcribe users' questions. For that, we used NVIDIA's Riva ASR because it's performant, it's accurate, robust to noises. Using these three different pipelines, we built our final prompt. We create the prompt that will eventually feed into the RAG and small language model pipeline. But before we do that, we also build a prompt optimization and guardrails module. This is extremely important because without having an optimal prompt optimization guardrails module, you will not get relevant answers, you will not get accurate answers. Your assistant will also not be safe to use. Sometimes it will answer things that a game developer will not want it to answer. So extremely important that we build that. As you see, we cherry-picked some models, RT-DATR for computer vision, Easy OCR, Queen 2.5, Riva ASR. We did not just, we ran a large set of experiments where we analyzed their performance, accuracy, and we narrowed down on these models because they were best fit for these use cases. We also created fine-tuned versions of those models and built plugins around them so that it is easier to use those models. Let's dig a little bit deeper into this pipeline in following slides. But before we proceed, we are calling this pipeline a third-party integration because in this case, your AI assistant sits outside of the game application. You can build this AI assistant as a third-party developer, getting the game data from wikis, using our frame capture libraries, and essentially getting an AI assistant for any game. You can use this same pipeline to build an AI assistant inside of your game. Actually, the pipeline simplifies because you do not need computer vision models, you do not need OCR models. Your game already has its own game knowledge base, which is source of truth. Your game also has a very accurate representation of game state. They are passed on to this pipeline, these models, and you can get the response. So this is actually easier for game developers to integrate in. It is also more performant because you are running fewer models. It is also more accurate because you have more accurate representation of game knowledge base and game state. If we look at the last two slides, these are essentially building blocks of an AI assistant. The ASR, prompt optimization, guardrails, RAG, small language model, computer vision, OCR, all of that. You also need some tools. You need a RAG builder tool, you need a frame capture, audio capture tools. And lastly, you need to know the best practices. How do you optimize, how do you do data curation, how do you do guardrails, how do you game benchmark? We have talked about how we cherry pick certain models for different modules, for RAG builder and frame capture libraries. I'll be spending rest of this presentation talking about best practices because that's something that we find to be extremely important in creating a good assistant. To build an efficient AI assistant, these are the 5 key points that a developer needs to follow. You as a developer need to curate your game knowledge database. I'll talk more about each of these points. You need to curate your game state information. You need to rewrite queries. You need to implement guardrails, and you need to use a benchmark to measure where you are in terms of accuracy and how you are making improvements as you make changes to a pipeline. Let's look at an example of best practices for curating of game knowledge database. What you want to make sure when you have your game knowledge database and you want to build a RAG from that, before you do that, you want to make sure that your game knowledge is human readable. It is structured for easy parsing. It includes information that is relevant to the users, because if your input data set, if your knowledge database does not have information that users are asking, it will not be able to answer, it will hallucinate. It should maintain a clear hierarchical information. In a game, you have several assets. You have your maps, your weapons, your players, your damages. You need to make sure that hierarchy is represented very accurately in your knowledge database. You need to make sure that you're deleting duplicates. For example, if you're curating a game knowledge database from GameWiki, from Discord, from your own inside, wikis and conference pages, make sure that the information is not repeated. And you want to make sure that you customize your data set to the very specific version of the game for which you are creating an AI assistant. Essentially, just like all of the other AI algorithms, it's garbage in and garbage out principle. You want to make sure your data is absolutely great quality to get a good AI assistant out there. And these are some of the most important pillars of getting your data in good shape. Let me share some examples on how we can differentiate between a good data and bad data. For example, on the left side, we have example of a bad game data set, bad knowledge data. You have weapon, sniper, X99, state is damage is 250, range is 800, fire rate is 1.5, enemy is heavy sword. Essentially, a lot of non-LLM friendly, not human readable variable names, terminologies, not structured well, not shown in a hierarchical form. On the right side, you have a very great representation of that same knowledge, where it says that X99 sniper rifle is a long-range precision weapon with high damage. It talks about the range, it talks about the fire rate. It's much easier for an LLM to interpret the data on the right side and give more accurate, more relevant answers. Similarly, so this follows the first two principles. Make sure it's human readable, make sure it's structured well. Similarly, this is another example of good game data and bad game data. On the right side, you have a game data which is, although it is in JSON format, it doesn't necessarily need to be in textual paragraphs. It's in JSON format, but it contains all the information about King Lorien. It contains the traits, it contains the backstory, traits, abilities, and affiliations as well. So, and the quest for this character as well. So all the information related to this particular character represented very neatly in a JSON file, with good description, human readable, doesn't need to be paragraph text format, but it just needs to be structured well. The hierarchy is represented correctly, human readable, structured correctly, no duplicates, and target for the game. On the left side, you have same information, but represented badly again in a JSON. So it's not that, JSON is a good format or JSON is a bad format, or any other specific representation of data is bad. It's about how you use that specific format that matters. On the right side, on the left side, for example, you see that the affiliations for this character are not mentioned in this structure, and probably somewhere else in that database that affiliation is present. But then for LLM, it's very difficult to make that connection itself. So as long as all of your hierarchy is correct, the data is correct, the structure is correct, you will get more accurate responses from your LLM. So extremely important. One of the possibly the most important thing that impacts the accuracy of your AI assistants. Next one, the game state information that either you are getting from the computer vision and OCR models, or as a game developer you're passing, you need to make sure that it is represented correctly as well. It needs to be in key and value pairs. Again, should be human readable. Ensure that the game state is not too large. It needs to focus on the part of the game where you are at, because within a game, if you're a game developer, you know that a game state is a large set of parameters that represent pretty much everything about the user in that game. But at a certain point in gamer's journey, at certain level, all of that information is not relevant. And if you pass in all that information to your AI assistant is going to produce confusing responses. So another extremely important thing to remember when you're building an AI agent, to pass in only the sections of the game data, game state that are relevant for the user at that particular point in game. Let me show an example of a good game state and a bad game state. Difference is the right side is more human readable. It is focusing on the player's key parameters, and it is not using abbreviations like the left side. Let's continue to move on. Third key aspect of improving accuracy of your AI assistants, make sure that they produce accurate responses, because that is probably the most difficult problem in productizing the AI assistant. It's very easy to do proof of concept for AI assistants. It's extremely hard to create a production quality AI assistant, because those getting that last bit of accuracy is extremely hard, right? So in this case, if user is asking a question, a query, you need to break up that query into more meaningful set of queries. For example, if they are pronouns in a query, your language model may not understand what those pronouns are mapping to. You need to do that mapping using a query rewriter module. Similarly, you need to break up a complex query into multiple queries and generate answers for them and polish those answers. Let me give an example of how do we do that. For example, this is the original query from the user. Which ones can I upgrade to increase my damage output? Now, if you send this question as is to a small language model, it will not behave well. You'll get inaccurate answers. What you want to do is you run it through a query rewriter, which is looking at your history to resolve these pronouns. Because in the history, it knew that you are talking about the weapons, then it replaces this which ones with which weapons, right? Which weapons can I upgrade to increase my damage output? Step 1, all the pronouns resolved, mapped to based on the history. Step 2, you break it down into multiple queries. Query 1 is what weapons are available for upgrading in the game at this stage, right? And how do these weapons affect damage output? You break this query down into 2 parts and send those queries down to your RAG and SLM pipeline to get accurate responses. Again, this is extremely important to get accurate responses to improve user experience. Otherwise, we have all come across a lot of AI assistants. They don't end up adding a lot of value. We don't find them actually useful. They are good as an experience. They are good as a proof of concept, but we don't use them day to day. These best practices essentially turn your proof of concept into something that adds value day to day and you can rely on. Next one, implement guardrails. Again, super important. You do that by doing intent classification. Your question comes in, you want to make sure that that question is relevant for the use case for which you have built that AI assistant. If you have built an AI assistant for your game as a game onboarding agent and somebody asks it political questions, you should not be answering those. You don't want to do that. Do intent classification if that question does not belong in a class that you want to entertain, you discard that query. That happens pre-RAG. Essentially, we discard those queries even before they hit our RAG and SLM pipeline, RAG and small language model pipeline. We also do a post-LLM guardrail wherein if language model itself generates an answer that you would not like to send to user, you can filter it out at that point of time. You can discard that. And there are very important use cases where you would want to do that. For example, if a user asks about some cheat code, some cheating strategies in a game, and because your game AI assistant has access to a lot of game knowledge, a lot of game state information, somehow it ends up producing a response that gives you a step up in the game, that a method to cheat in that game. You would not want that to be shown to the user. So on the output of SLM, on the output of this pipeline, we run another guardrail to make sure that those responses are filtered out. It can be keyword based, it can be based on classification of the responses. We filter out, for example, if LLM ends up generating some code that can be used, scripts that you can run in the game, we filter all of that out. Lastly, in order to productize an AI assistant, you need to use an AI game assistant benchmark. And I cannot emphasize the importance of doing that enough. Building a good benchmark will allow you to measure your accuracy. It will allow you to measure your drawbacks, your weak points, and will allow you to measure your gains as you make changes into your pipeline. We have created our own benchmark that we use, AI game assistant benchmark that we use to measure how we are doing when, as we continue to make progress on these pipelines, on our data. And we do intend to share more information about that once it matures as well. Finally, we have been on this journey where we experimented with several models, curated, cherry-picked the right ones, fine-tuned them, optimized them, where we built tools to build RAG solutions to do frame capture, audio capture, where we built guardrails and prompt optimization modules. We built benchmarks for AI game assistants. We want to have game developers and other app developers benefit from this work. we are in this journey where we still have some problems that are open that we are working on, where we are maturing this work. But a lot of this work can be used as building blocks, as high-level building blocks to quickly get to a production quality AI assistant inside of your application. If you want to bring and build an AI assistant within your game, rather than having to walk through this entire process again, where you are optimizing it for several goals, for making sure that it runs locally, optimizing it for accuracy, you can use these building blocks and just bring in your data, use these tools, use this SDK to create your assistant. So our objective is to use the work that we have done, turn it into an SDK, easy to use high-level SDK for game developers and app developers, where they can create their own AI assistant. So we are somewhere in that journey. We'll be bringing in this SDK to public, to our game developers very soon. And this will be a well-structured SDK with SDK headers, libraries, documentations, best practices, benchmark, all of it. Essentially, everything that you need to create your own AI assistant. We are all really excited about it and hope to see it out in production soon. Thank you. Are there any questions?
Mic.
Yeah, can you please come to the mic? Yeah.
Thank you for your great presentation. I have two questions about technical one. So one is the game about the game wiki. So how do you handle game wikis which have the images or structured data such as tables for now?
Right. So if the game wiki contains tables, images, other kind of media as well, our data processing scripts, they are generating an interpretation for those formats. So we generate data from the images as well. We annotate them. We kind of derive data from the images, from tables, and also make sure that when we do that, they are structured correctly in the resulting data. So we are actually using all the data, not just text, but images, tables, everything else on the wiki.
Okay. So I think that is so reliable, ideal one. So yeah, thank you. So second question, the maybe future work for use. So and I wanna ask the robustness about this assistant system. So does it need to be optimized for each games or not?
Yes. So there are two parts of integration. If you are developing this as a third-party app developer, not the game developer, and you want to optimize it for 10, 20 different games, you will need to optimize it or onboard it for each game, because the game data is different for each game, and you would want to curate it, fine-tune it, so that you can train your vector database on that. So there is that onboarding step. Also, the computer vision models, they also need to be optimized and fine-tuned for that specific game, because each game has different weapons, different assets, and you want to optimize your computer vision models for that as well. So yes, there is an onboarding step for each game.
Yeah. So I thought that was so costly.
Yeah.
Think it's so costly. So if you have any ideas, I wanna ask the some better method for the using the RAG module.
Right. We are, like I said, we are somewhere in that journey. We're working on making it more generalizable, more robust, and hopefully by the time we come out with this SDK, we would have solved some of those problems and made it easier to onboard those games. Maybe more scripts, more best practices, right? So that even though you need to onboard for a new game, it becomes as easy as running off your scripts.
Yeah. Okay. Thank you very much.
Thank you.
Hi, thank you so much for the talk. I was curious about a few things, no, just two things specifically. For talking about optimizing the game AI assistant and developing the game, what does it look like for the input to the game AI assistant? Sorry for this noobish question. You might have shown it on the display already. Is it supposed to be a text file that's eventually fed into the LLM for pre-training or RAG? Or is it supposed to be looking at just specific JSONs? Or is it looking at all the files that are in the executable? Or what does it look like?
So to train your knowledge database, you can use different types of, different types of files. You can use text files, you can use JSON files. The format of the file, there are a few different types of files that we have worked with and we will likely support, like HTML, text, JSON, right? But like I said, the format of those files is less relevant and less important than the content of those files. So the content needs to be structured correctly. But your standard files like text files, JSON files, HTML files will be supported.
Okay, I'm not trying to focus on like the type of files. I'm just trying to figure out like what is it looking at all. So it's looking at basically everything that's part of the game as far as files go.
Everything that you pointed to. So as a game developer, you need to point it to the data set of files, right? So it's your choice whether you want to, what you want to point it to.
All right, and my last question is you partnered with Wildcard for this. Did they talk about what the overhead cost of this was for developing it? Did they have that in mind already, or did they develop the game first and then you introduced this technology and then they had to do some additions?
It's not their fault. Yeah, it was. Well,
For that specific demo, and the game wasn't touched at all. It is built completely outside of the game. The wiki data was used as the source, and computer vision was used for deducing the game state and responding to the queries. So if you're an app developer working outside of the game, that's a perfectly valid way of onboarding a game, as long as you have all the necessary access to the data. You don't have to make any surgery of the game. But if you're integrating into the SDK that Ambrish is building, then it is ideal that you have access during development or during by the team that's developing the game. It's usually easier to do that stuff.
Okay, awesome. Thank you so much for answering.
Hi, thanks for the presentation. And I just have one real quick question about because when the AI assistant interact with a player worldwide, so there is a need for the multi-languages. So I want to know how do you address the translation challenge for the AI assistant in both the major and the minor languages?
Okay, great question. We have experimented with some languages, but we are not at a point where we can support a large set of languages. We are working on that. Anjul, do you want to?
Yeah, to that effect. Yeah. So most of the speech and the language models that we have experimented, specifically the ones that we have using currently, have a generally broad language support, but it is more for major languages than minor languages. Our support, especially when we build in the SDK, some of these models are interchangeable. Like you can use an LLM or even a speech recognition model from a different source than the one that we're using, which may have a better language support. And in those cases, it would work out. The only caveat is the source of data. It should ideally be in the language that the agent would be running. But like Ambrish said, that the language support section is something that we'll still continue to work on and make it more robust.
Yeah, and when we do release this SDK, it will come with essentially a list of languages that it has been tested with and that are known to work well. So we'll start with that, and likely we'll keep expanding that scope of support for other languages.
Okay, thank you.
Hi, so this is really great work, and it's exciting for me because I'm working with a group at Cornell focused on making virtual guides for people who are blind to help guide them around VR spaces. And this seems like a great application. So I guess the two questions I would have, the first one is the customization of the output. I think we've done some experiments and found that people react very differently to an AI assistant that is like a robot versus a friend versus a butler versus a magical godmother, right?
Yeah.
So with this type of model, especially the small language models, how much control do you have over the ways in which the AI assistant responds and what types of information it gives you?
Right. We have not experimented at length with different personas for the AI assistant, but our experiments do show that although it's a small language model, it's very capable, and I would expect with a high degree of confidence that with the right prompt engineering, you can build different personas there. In our experiments, this small language model functions really well. It was able to produce similar responses at other cloud-hosted more large language models. So with a very high degree of confidence, you should be able to build personas with different prompt engineering. But that is not something that has been our focus. Our focus has been primarily optimizing this assistant for accuracy and gaming a specific use case, but the same pipeline can very well be used and customized to different personas.
Gotcha. And then the second question is, so this is mostly just text output, correct?
Right, yeah.
Right. So, for us, we found it can be helpful to get a question of an answer of, oh, go over there, do that. But it's also very helpful to maybe put a beacon on the objective you should be going to, or other kind of in-game experiences and things.
Yeah.
How big of a jump technically is it from going to this just text-based output to output that lets the AI agents interact directly with the game?
Right. So this is something, basically what we call function calling functionality, right? Or building function calling capabilities inside an AI assistant. That's something that we have experimented extensively inside at NVIDIA. And at some point of time, we will be bringing in that capability. I'm not sure whether it will be in our first release of the SDK, but we definitely do intend to add function calling capabilities at some point of time in future. It's a known problem. It's a solved problem. We have done that at NVIDIA just for different use cases. So when we take that and bring that into the SDK, it's an open question right now. But we know how to do that. We have done that for the use cases, and it's not, I wouldn't call it as big a technical jump.
That perfect.
Yeah, these models are perfectly capable of doing function calling.
Great. Thank you very much.
Hi, great presentation, thank you. And I'm curious about if the game has some its own vocabulary or its own acronyms. Do you do anything special to support to input those information into the into the LM, or you just relying on the RAG to handle it?
There are a few places where the game-specific vocabulary would feature. I think the most important is the RAG, which would contain all the elements of the game, and the two other minor places would be word boosting input for the speech recognition or speech synthesis modules. So basically, if the game has special words that are, let's say in some new language that it's only valid in the game's virtual world, then often the speech recognition systems have a challenge in recognizing those words. And so the accepted way of that is to employ word boosting with a small dictionary of the special terms in a game that will help the speech recognition module recognize those words when spoken by the user. Similarly, if there's a speech synthesis engine, the same thing would apply. The RAG would be the second place where this would happen, and the third minor place would be the system prompt that is provided as a global thing alongside every query. That can provide additional input about the common terms and languages used in the game. Those are three places where the game-specific vocabulary would be part of the the way it processes queries.
So for the speech recognition part, did you say there were already some tools to let you to input those vocabulary?
That's right. It's called word boosting, and so you can provide additional words that you think are likely to be spoken by users. Okay. And so whenever the recognition module has a conflict or trying to weigh different options for certain speech that it has heard, it will give a higher weight to the words that are in the vocabulary that you provided that are boosted.
Okay.
Yeah.
Okay. Thank you.
So I remembered one more question.
Sure.
In terms of performance, so thinking about running these types of applications on beefy gaming computers versus discount computers versus mobile phones, how powerful does your graphics card and does your computer and RAM, et cetera, have to be in order to run these types of AI assistants, especially on top of a game that may already be demanding?
Yeah. So far, we have been able to run this with pretty much most of RTX GeForce GPUs like Ampere, ADAS, Blackwell. They work well. We have not tested it on phones or other platforms right now. It does require, it still does require a reasonably powerful GPU to run this as well as a game. So right now.
Gotcha. Okay, thank you.
Yeah. Great. Thank you everyone for joining.